The half-life of radon-220 is 54.5 seconds. What mass of this nucleus is equivalent to 1 millicurie? So, you have been provided with a half-life. How will you find it out? If you are provided with a half-life, it means you can find out the lambda, that is a radioactive decay constant. But it is saying, say if I write it in simple question, a simple form, it would be how much of this thing radon 220 will give disintegration equal to 1 millicurie. Now 1 millicurie is equal to how many disintegrations per second? It would be 3.7 into 10 to the power 7 disintegrations per second. This is a standard unit. You don't need to use your brains here. There is a standard unit, 1 curie is. Right? Curie is what? Curie is the unit for radioactive disintegration. Now, your activity, what you need to find out? Now you know the activity. What is the activity? 3.7 into 10 to the power 7 disintegrations per second is the activity. So your dN by dt is equal to lambda n. Now what is your n over here? This n is equal to number of atoms of radioactive element, right? So this is number of atoms of radioactive element. Right? Now, we know the activity. How much is the activity? It is 3.7 into 10 to the power 7 disintegrations per second. That divided by lambda, and that is equal to n. Now what is lambda, students? Lambda is equal to 0.693 divided by the half-life. So what is the half-life given over there? It is 54.5, and that will be equal to, so it would be 0.693 divided by 54.5. That is 0.0127 per year. Now, can you find out n? N will be equal to 3.7 into 10 to the power 7 divided by 0.0127. That will give you your n, that is the number of atoms. So, this 3.7 into 10 to the power 7, and that is divided by 0.0127. So this comes out to be 2.9 into 10 to the power 9 atoms. Right? Now, what is the formula for number of atoms? Number of atoms is equal to number of moles, that is weight in grams upon molecular mass, multiplied by 6.023 into 10 to the power 23. So can you find out the weight now? W will be equal to N, that is 2.9 into 10 to the power 9 multiplied by 6.023 into 10 to the power 23, and that has to be divided by that has to be, I think, multiplied by the molecular mass. This will be in the division part. So here what I can do, students, I will multiply this with the molecular mass, that is 220, and divided by 6.023 into 10 to the power 23, right? So you will get your weight as, just divide it and multiply it. It will be 2.9 into 10 to the power 9 into 220 and divided by 6.023. So it would be 1.06 into 10 to the power minus 12 grams. So this much amount, that is this many grams of radon 220 will give disintegrations equivalent to 1 millicurie, right?